Hello, everybody. I'm just talking, I wanted to present you some new functionality that will be introduced in Cassandra 3.0. It's called UserDefined Functions. I think it's a great feature, especially for everybody, since we told people not to use any code in Cassandra. Some words about me. I'm just a contributor to Apache Cassandra. I've built the UDF stuff. Currently working on the rogue cache for 3.0. Basically, I'm working as a freelancer on my own, helping customers to build good Cassandra solutions. Cassandra 3.0 is brand new and actively developed. So everything is under development. Everything may change. So please don't blame me for anything I tell you now. It might be changed. So Cassandra 3.0, it will bring a lot of new features, as Jonathan already told today. A lot of new, great improvements, and user-defined functions is just one of it. So what's it? It basically means user-defined functions. So you can go ahead and start writing your own code, let it execute on the Cassandra nodes. And one thing I'm really proud of is that your own code gets automatically distributed to the whole cluster. Yeah. So please take the last sentence note word by word. Characteristics of a UDF. The ticket is called pure functions. By pure, we mean just input parameters, primitives, usually. No state, no side effects. No dependency to other libraries, like pulling in some messaging system, for example. Don't do that. Don't even do maybe DNS lookups or something like that. So basically, who's a Java coder? Okay, so you understand that function. That's what we mean when you say pure function, nothing else. As I said, it's basically simple to set up a user-defined function. So you have a bunch of arguments, 1 to n. You have a return type. You specify the language you're using, and you specify the source code you're using. Yeah? Will be injected into a class which it's transparently built. You don't have to bother about it. Yeah? So just arguments, a return type, and some language. It's even possible to not only use Java. You can also use any scripting language like JavaScript and do it like this. Yeah? And even this one. Whoops. Sorry. Wrong slide. It's JSR 2.3. It's scripting for Java platform, so we basically did it. So you can write in Java, JavaScript. Even if you want, you can install on your own. Support for Groovy, JRuby, Jython, Scala. Closure is actually not working. It's not because of us, it's because of the implementation. So behind the scenes, it takes the code that you have written in the create function statement. It builds the Java class or the script file, compiles it, it loads the code, and it transparently migrates it to every other node in the cluster. It's similar to a create table statement, create index statement, like that. And now it's executable in the whole cluster, on every node. So the argument types for those functions is basically anything you can use in Cassandra in the table, like Boolean, integer, even collections or tuple types or the new 2.1, excuse me, user-defined types. Basically, we did it by pulling in the Java driver. That's it. So, yeah, what it's for. What you now have seen, you can't do it even, not much better as you can do it in your application. Yeah, creating a seamless function, what it's for, yeah. It's not a great new feature to do summary of anything or calculating simple functions. It's not that bad. So basically, they're just nice to have. Nothing you can do better on your own. So there is a real use case, of course. And that's one, even new in 3.0 is aggregate functions. So you can do it on your own. So UDFs are used inside the aggregation functions, like sum, average. So who doesn't know what an aggregate is? Good. Oops. That's basically the syntax to create an aggregate, your own aggregate. If you want to code a minimum function, just give it a name, some argument, some state. It has to maintain a state when it scans the rows. And the name of the UDF it's used to calculate the minimum. Yeah. Basically, working internally is it has an initial state, basically null. For each row that will be scanned, it takes a state, or gets a state in, including and the value of the rows, calculates a new state, returns it, and the last state will be return value. So what you previously had to do is scan all rows, return them to your client, and calculate the minimum on your side. It wouldn't work for something like an average. Yeah? You have to sum and to divide by the number of rows. So you need something that works after the last row to calculate something. It's called a final function. And here you can see, for example, that you can even use tuple types. You know what tuple types is? Okay. Tuple types are just, as you can see in the syntax, it's just one type. It's frozen in 2.1. Just a sequence of some data types. So the initial state would be 0 and 0, and the state function, which called is for every row, is the average state. It's the state of the tuple, and the final function would return the average. Yeah, that's basically it. I think it's not the intention to execute evil code. That's what I meant when I said don't pull in any evil dependencies, costly dependencies, things that have to wait for something else. That will slow down your whole cluster. I think you don't want that. That's what we also want to do in 3.0. Add some permissions for DDL statements, for DML statements, whether you can execute a function or not. There are also still the functions you're used to use, like now, count, timestamp off. They are now called native functions. And there's a reason that they have to belong to the system key space. It's just because you can't modify them. You can't even drop them. So each user-defined function or aggregate just belongs to a key space, like a table or user type. If you do not specify the key space with your function, the system key space is searched first. The reason is just the native functions. Yeah. To keep it backwards compatible. Yeah, some words about it. As I said, scripting, it's nice. It's really nice if you can code Scala or Groovy, something like that in your, and let it run on your cluster. But you have to keep in mind that scripting has a lot of overhead. During some tests, I found out that the overhead just to execute, for example, a JavaScript, is about 1,000 times slower than Java. Yeah. Keep that in mind. I would strongly recommend just to use Java, plain Java. Keep the UDFs pure. Don't just take the parameters, work with them, and return a result, not pulling anything in, and test them. I don't think anyone wants to deal with, for example, a null pointer exception running in a production system. Yeah. Still looking ahead for the tickets. The aggregate stuff was built by Benjamin Lehr. He asked me to, he said, I'm a geek. I just want to know a bit more why it's executed on the coordinator, why it's not just, for example, for an aggregation distributed to the whole cluster, and the whole cluster does work and returns the results back. It's executed on the coordinator because the coordinator, only the coordinator, has all results, all individual results. And that's it. As I said, please prefer Java over anything else. You can do it. I think it's a great thing, but for prototyping, trying things out, but yeah. Still turning it. We're just dreaming a bit, because UDFs could be used for so many things. Indexes, for example. Indexes by themselves are not quite good. But you can use them, could use a UDF for a create index, for example, as Jonathan said in this presentation, for partial indexing, for more advanced filtering. And even, it might be a bit complicated, a bit complex to implement, but such a thing like a distributed group by, where the individual nodes can aggregate data on the partitions they own and return these sub-partial results back to the coordinator, and he does a final merge on it. That's basically what UDFs are. I kept it a bit short. Wasn't that good in timing. I'm sure you have some questions.
Can you pass a blob?
Please?
Can you pass a blob object to UDF?
Yeah, of course.
And is there a limit to the number of lines of code UDF?
Basically not.
So you could do some simple image processing, for instance, inside the UDF on the blob?
Yeah. We get a byte buffer. It's basically just the types that you will use to get in Java driver.
So it allows you to select all images that have a certain feature, for instance.
Please, can you repeat it?
Sorry?
Can you?
You could do a select all images in rows that have a certain feature.
Yeah. But it would be basically just a full table scan, of course, yeah.
Two questions kind of related to that.
Okay.
How is this going to interact with the allowed filtering restrictions in SQL?
Mm-hmm.
Because this is going to allow you to push a lot of filtering operations to the server, but SQL won't actually allow you to execute it at the moment. It'll say, well, you can't do that, it's too expensive.
It will be expensive, of course. If you do such.
So you're planning to remove the language restriction that currently exists in CQL?
About that filtering, regarding the previous slide, it's just basically dreaming. Not sure how to implement it. I think it's worth to reduce the network traffic from the cluster to the client. That's it.
But this new functionality is going to have to interact with the existing restrictions.
Currently, yes.
But it's different. Allow filtering is there when you query an index and you have to first get back the result.
I want to pull tables down and you've got to let me do that. There's some clauses I just can't express because allow filter is too restricted.
But you have the same thing. The only thing is you can use it. Of course, you can always use things like that to hack around.
Yeah,
But
so this is basically map reduce, right? I want to push my logic into
no,
user-defined
not at
function.
all. Because the thing is happening on the coordinator node. So basically, you query the cluster, get back your result, make sure you have the latest data, then you apply your function or your aggregation on top of it.
Okay.
But you don't push the function to the node.
Correct. So kind of semi-related to that, you mentioned earlier the problems of distributing code around the cluster.
Not problems.
In something like image processing, you want a library or some kind of big chunk of code there that your function is going to call. What's the process operation?
Okay.
That kind of situation.
So you want to do image processing using...
I want to do something arbitrary, but for example, I have data in protobuf format, so I get a blob, a byte buffer.
Yeah, a big blob, yeah.
Protobuf library to decode it.
Hmm?
How do I get that library in my cluster?
Not. That's what it meant to be pure, not to pull in any foreign dependencies, because that would be dangerous. Especially if you say you want.
To me, it's in the functional sense of side effects, so it's wholly dependent on the language.
Yeah.
So something like decoding protobuf is actually pure in that sense, but I need a big chunk of code to do it.
Yeah.
Could you add a jar to the class path?
Excuse me?
Could you add a jar to the class path?
Technically, you have access to the class path, but
Would that work with UDFs?
I wouldn't recommend it. Definitely.
You are in class path and load it anywhere and do whatever it's like. So.
Do you have any benchmarks against like standard writes and then maybe writes that use standard reads or writes and reads or writes that use?
So basically, the comparison about which impact has the UDF.
Let's say I had a UDF that just added two numbers together. If I put that into the read part, what impact does that have on?
Not really much, because if you stick to Java, because it will be jittered is a bit too much, but it's just an execution. So we are talking about nanoseconds, maybe some microseconds for each row. It will grow if you use JavaScript, because then you get easily in the millisecond. That's it.
In terms of memory on the coordinator node, won't that take a hit now because you are sort of getting all your results back from all your nodes and then so your takes a hit as opposed to your client?
It has some impact, yeah, but it depends on you what you code. If you just do A plus B, it's nothing more. It's just basically, technically behind the UDF is a Java that implements an interface and has just one instance of the Java class in the whole VM.
So what I'm trying to understand is if everything is being done on the coordinator node, what's the difference between that and a client? What do you get?
I don't think I got your point. If you're just talking about pure UDFs using in a select, for example, it's nothing, really nearly nothing.
In terms of the Aggregation example you give, is there any plans on moving that into kind of more of a MapReduce style where the storage nodes are doing it?
Yeah, that was the intention of the distributed group by. It's just an idea at the moment.
So that can be very powerful. That can really cut down the amount of network traffic.
Yeah. You can do that with, could do that with an aggregate, for example, yes.
In aggregates, couldn't you only invoke the final function on the coordinated node and do the rest of the processing?
That would be the idea, yeah.
Is there any way to monitor the outputs? For example, these functions, they can take up memory or time. Is there anything that is built in right now?
I'm not really a fan of such a thing that gets caught for millions of rows, because monitoring takes time, and it's
Like JMX.
JMX.
But the question is more precisely, what do you want to monitor?
each individual function has.
Execution time and space, because the more memory you have, it
Space
creates pressure on the JVM.
Space is the same as it used to be. The same, because what's happening in Cassandra coordinator is you get back your result, you build your result set, and you send your result set to the user. What's happening there is that while you build your result set, then you apply your functions. So the data that you store is the result of your function instead of the original value of the column. So it doesn't take really much more memory.
But even a function, you can create space. If you in your function you have to use a hash map or something like that to create space.
No.
Yes, it is.
Okay.
You have one instance of each function per.
But the function is executed inside the body of the function. It can create objects. It can allocate memory.
Yeah, it allocates one memory per page that you get. One object per page. So if your page is the default one, so 10,000 rows, then you only have one object created for this 10,000 rows.
Yes, please.
Are the user-defined functions strictly only for processing queries? So are you able to, when you get data back, write stuff like that, basically build pipelines with them?
You could use them also for inserts and for updates. It's possible, yeah.
So you can do your aggregates over the entire primary key, right? That you have to specify a primary key and then sort of inherit.
You can aggregate basically on everything you can do with a usual select. Just you get the aggregate back.
Is there any thought in grouping within that primary key? Like in other words, grouping based on the clustering columns? So you could get a max for a time window. You know, if you had a clustering column of say month or year, let's say year, you have the max per year for a given primary key or part.
It would be great to think. Yeah, it would be great to have such a
It's
thing.
a short step to
Yeah.
full group by, but you're still only operating in a single partition.
Yes, please.
Can you run several aggregations at the same time?
Yeah, of course.
Some on average.
Especially if you stick to Java, because there you have nearly no concurrency problems. I'm not sure about the JSR implementations regarding closures, not closure, but the other scripting languages.
I'm thinking like select some amount, then comma, average, something else, like that.
That's possible, yeah.
Will UDFs give more clarity to triggers?
Please?
Will UDFs give more clarity to triggers? Triggers are currently a work in progress, right? They haven't finalized what the design of triggers will be.
Sorry.
Okay. Triggers in Cassandra.
Yeah.
They haven't finalized the flow because it exposes a lot of internals of Cassandra to the person who's writing the trigger. So will UDFs give a more clear picture?
Yeah, it's a completely different approach than with triggers. Triggers were placed on every node as a jar file or as class files. UDFs are just coded in CQL, so you don't have any. We don't even expose internal information to the UDFs. Did it answer your question? Yeah. You mean in the schema? Yeah. It's basically a new schema table or two new schema tables. Yeah, it's just the migration for the tables or something like that.
Is that per key space?
Of course. So.
Can you reference a function from another key
No.
space?
No. Basically, yes. But then if you intend to use, for example, user-defined types, you will get into problems because you can't use user-defined types in another key space. That's it. It's possible to invoke them, of course, yeah. But be careful. Don't mix things from, let's say, different domains. Okay. Any more questions? So I think I'm pretty good in time. Maybe a bit too short, too fast. Yeah, thanks for your attention, and have a great day.